PTQ Magazine and Digital Refining are pleased to bring you this webinar featuring Tracerco. My name is Ken Molay. I'll be acting as your facilitator today. You'll be hearing from two subject matter experts today. Oliver Riddle has an engineering degree and a background in mechanical design. He's been with Tracerco almost 3 years and is responsible for managing customer nucleonic instrumentation installations across the UK and Europe. Rufat Mamadov has a degree in automation control systems and an MBA with 17 years experience at Tracerco. As a project engineer, Rufat specializes in managing upgrades and optimizing customer nucleonic instrumentation installations across the Middle East and Caspian regions. We'll hear from Rufat in a little bit, but for now, I will turn off my camera and hand it over to Oliver. Oliver, it's all yours.
Hi, everyone, and thanks, Ken, for the introduction. So my name's Oliver, and I'm here with my colleague, Rufat. Today, we're going to go through how you can optimize your process and reduce downtime with our instrumentation. So to start with, just a very brief overview of what's going to be covered today. We're going to take a look at Tracerco, the principles that underpin the technology, before moving on to our fixed instrumentation range. And at the end, we're going to talk about a process improvement case study before taking any questions that you might have. So Tracerco have been in operation for around 65 years, and we were founded to create a solution to an industry problem. We were part of the ICI group, one of the biggest chemical manufacturers in the UK. And since then, we have grown significantly, expanding our product and service range as the years have progressed. So what do? We provide a total solution in process analysis and optimization by creating innovative ways to measure the difficult to measure and offering insights which are going to empower you to make better informed decisions, be safer and more productive. So why would you actually use nucleonics? Well, these are favoured in some of the more harsh environments or conditions where conventional instruments just don't cut it, or where they can't measure effectively. With the nucleonics, there's an increased accuracy and reliability. The use of gamma isotopes provides a continued output, which means there's no switching off. A few examples of these processes where it's particularly useful include fouling or clogging, erosive and corrosive processes, high process temperatures, or varying pressure and temperature conditions. So just going to take a quick look at the first principles and a very high-level overview of how our nucleonic technology actually works. So the products and services that we supply are mainly radiation-based, and there are different types of ionizing radiation. So what's first going to be shown here is an alpha particle, and this will just pass through a little bit of air and be stopped by a piece of paper. The second, the beta, won't be able to go through foil, but is a little bit more penetrating than alpha. And then what we actually use is the gamma ray. So this gamma ray is something that is not stopped by anything, it's just attenuated or reduced. This is a very penetrating one, and this is what we use when we measure our instruments. It's this attenuation that we measure when it comes to the products and services that we supply. And by looking at the change in measured dose rate, we can determine many different process variables in the instrumentation systems. So ionizing radiation is what we use, and this is a type of energy released by atoms in the form of particles or electromagnetic waves, and it's got enough energy to remove tightly bound electrons from atoms. Now this can lead to the creation of charged particles called ions, and this process can damage living cells or DNA. This is why it's really important that radiation is controlled and used in a sensible manner, and that underpins everything that we do at Tracerco. Examples of these ionizing radiations are something like X-rays and gamma rays and the particles that we mentioned previously. Just over to Rufat for the next part.
Thank you very much. So typical process challenges. What's the main challenges we see when we're talking to our customers? Changes in the process condition which leads to offset or incorrect level output, potentially bringing the trips in at the wrong point. Reduced reliability with a high amount of plant shutdowns, all impacting our operating cost and reduced outputs. Physical damage to the plant caused by corrosion and fouling. High amounts of chemical usage to improve purity and emulsion control, such as demulsifiers and anti-foam agents. The downstream process may receive process and fluids out of spec. How do we overcome this challenge? We evaluate the your application requirements to propose the most suitable solution for your need rather than the one solution fits for all. In its most simplest form, we'll position a shielded source and detector on the vessel walls to measure the change between the gas and the liquid. The size of and activity of the source is calculated based on the vessel design, such as the wall thickness and insulation and the process content. There is a variation to the depending on the application, which enable you to measure more than just the bulk level in the form of interface and density, or a mix of all three in a more advanced instrumentation. So all of our equipment involved in non-contact solution, where there are no interaction between the device and the process or source with the process as well. There is no moving parts with our equipment, which improves the reliability, repeatability, and accuracy in outputs. The system are easy upgrade for retrofit conventional instruments. There is a wide range of the product to be tailored to the individual plants and needs. Some of them is XIA, some of them is EXD, with multiple wiring options available various safety integrity levels, such as SIL2. Although still use some application standard equipment used to use a scintillating technology, which would see original reduction when there's a buildup on the foam presence. This would be higher level than what's actually inside the vessel. This measurement would not be repeatable and can lead to lack of confidence in the level system. For example, varying gas pressure or density in a measurement range can attenuate radiation to reduce the signal and result in higher than the indicated level. Radiation signal reduce, level increases. That's example. So our level plus solution uses Geiger Müller tube technology with a proprietary software and hardware that can be used for the pressure and temperature compensation, with ability to bring external pressure inputs or the use of theoretical pressure compensation. Advanced algorithms in the software are able to overcome the issue mentioned above, including scaling, foaming, pressure variation. Feedback given shows that this improves the operator confidence and maximizes the production. The software is able to indicate where the potential build up in the vessel with a measurement range, allowing for maintenance to be planned. So one of the Tracerco solution, it's Level Plus, is advanced nucleonic instrument for bulk level measurements. There is a first and only nucleonic instrumentation to provide highly accurate and repeatable nucleonic level measurements in the presence of process deposits and process changes. Using Tracerco patent technology, the PRI 150 is a breakthrough in the level measurements. Unique processing algorithms provide unparalleled insight into the vessel operating condition, monitoring with what occurs in the vapor space, allowing the extended deposition to be identified. And the next generation of our Level Plus includes a SIL2 certification with a similar high accuracy and repeatability for application, which have the safety function taken with an instrument. We are able to combine multiple detectors to provide a larger measurement range, for example, up to 80 meters, while it's still certified to SIL2. The software is configurable for both outputs of trips and level, and is non-intrusive. As I said, it's non-intrusive to the process. So the Oliver is going to introduce you to the density measurements system.
So the density measurement utilizes scintillation technology, and this technology in this application means we can use a smaller source size with a higher sensitivity detector, which allows for much greater accuracy in density measurements. These can be used to control and monitor interfaces and densities. A single detector can cover up to 3 meters of range, or for a longer application, multiple detectors can be daisy-chained together. The product has an inbuilt relay or analog output, and it does not require any hardware in the safe area, making the installation very smart and easy. In this application, the product is resilient to the majority of NDT testing, as a crystal monitors a different energy than what is usually used in the testing, such as X-rays. Tracerco's unique spectrum scanner technology allows for superior temperature and aging correction, while providing a better insight into the conditions of the process being measured. And the health status of the instrument is also provided every second of the measurement. The advanced signal processing of the density measurement system provides a base for enhanced discrimination to offer protection against the higher ionizing radiation fields that may be encountered, such as radiography. It employs dynamic compensation that accurately compensates for the effect of the ambient temperature variations and aging in the scintillator. This is achieved by tracking and maintaining the position of the radioisotope photopeak through varying the gain of the system. This allows the density gauge to operate over a wider temperature range from minus 55 degrees Celsius to plus 60, and this gives an output stability of less than 30 parts per million per degree Celsius. In addition, this method also corrects for any aging in the crystal that might occur over longer periods, and that reduces the frequency of the recalibrations. Each system is designed to match the process and vessel information provided, and the source that is used is sized appropriately with the lowest size feasible, which will match the regulations for the region that it's going into. The output can be used for deposition monitoring, and this is done by measuring the density on the count rates. As the density appears to increase, this would suggest a change in deposition. It's also been used in mass flow and conveyor applications. In some applications, the source can be used inside a dip pipe. This is still a non-contact solution and can provide accurate interface trips or interface level measurement. It can be used for both liquid-liquid and liquid-solid interfaces, such as sand or build-up accumulation. The application leading and most advanced technology available on the market for multi-phase measurement and control is the Tracerco Profiler. This has been developed over the last 25 years, with each iteration improving on the last and introducing the latest technology. Phase measurement began with multiples of a detector installed on the vessel wall, and this gave us the ability to profile the phases within the vessel to a reasonable degree of accuracy. Our competitors still offer this type of external solution, and the resolution is around 6 inches. The installation cost can be high due to the amount of brackets and cabling that's required. These systems are typically made up of 6 to 8 detectors to cover the critical interfaces, but it can be larger depending on that design. But if one of those detectors were to fail, it will affect the full system, and the output of that will also be affected. The installation is particularly heavy, and the output can be impacted by radiography. So a little case study on the dose rates that are seen using this system. This case study was completed to analyse the whole body dose rate implications of an external system. The radioactive source inside the standard conventional instrument is made up of 7 source capsules, each containing 30 millicuries of cesium-137. Typically, the higher the dose rate of the system, the more accurate the results are going to be, as there's a large change in count rate that is observed. But this gives a much higher dose rate on the external vessel wall, as shown in the graphic. But generally speaking, this is okay for flooded vessels where the process attenuates some of the radiation, reducing that dose rate. When the external system is able to measure the interface level using this attenuation in radiation, where there is water in the vessel, the count rate is shown to decrease, showing an increase in density. The detectors observe this difference and will give the output based on the calibration set points of the fluids. When the vessel is not ran in a flooded state and air is introduced into the vessel, the dose rate in this example was calculated to be over 400 microsieverts an hour on the vessel wall, and that was reduced to 60 at a distance of 1 metre, which is still significantly higher than the UK legislation would allow without the introduction of added control measures. It's also important to note that the external detector system cannot perform with respect to a high enough accuracy when the vessels are not flooded. This requires reducing the activity of the source that would normally be in air, as to avoid high dose rates externally, and if the interface level increases, the activity is not high enough to differentiate between the oil and water. Rufat's going to take you through some of the principles of our Tracerco's multi-phase measurement.
Thank you, Oliver. So the Tracerco profile typically comprises of 2 or 3 dip pipe assembly installed in the vessel through the single nozzle. A narrow dip pipe holds a chain of low energy gamma sources, while the remaining dip pipe holds an array of gamma detector GM tubes. Typically, each source is directed using a collimating rod into two detectors above and below the plane of the source. This collimation reduces the number of low-energy gamma sources used, stops radiation in all directions except that all to the detector. This creates a continuous measurement range by directing each radiation beam up or down. Measuring density change in this way allows for the most efficient operating condition to be maintained, as well as monitoring effectiveness of chemical additives and mud washing regimes. So Tracerco offers bespoke design. We say that's a fully customizable design tailored to the vessel, process condition, mechanical adjustment with adjustable resolution and density accuracy to meet specific application needs. Simply speaking, you provide us a vessel design and we'll try to provide you a really good solution for that. And then what's some of the examples shown at? It is a standard high temperature profile, we called, serving as a reference of typical configuration and application, such as a desalter. I'm going to briefly talk about the safety aspects as well, and as Oliver said about the conventional instruments and the radiation profiling. This is our study. You can see measures internally with a short source detector and pass as a profiler, ensuring no external radiation exposure, regardless of process condition on the measurement range. And we're just going to compare two of them. So when we look at using low energy gamma profiler versus high energy for external detector system on the right, we see profile results. No additional dose is in the surface of the vessel. For the external system to work correctly, there must be dose rate in oil so that the interface can be differentiated between. It is also important to note that external detector system cannot be formed with respect to high accuracy when the vessel are not flooded. They requires reducing the activity of the sources that would normally be in air as to avoid the high dose rate on the vessel wall. However, those are externally, and if interface level increases, the activity is not high enough. What's it going to be? There is not enough to differentiate between oil and water. So the example which is shows here, there's two systems. One is a profiler ready to source inside the Tracerco collimator. It's up to 30 source capsules, each containing 1.1 gigabecquerel of 30 millicurie americium-241 sources. The sources were assumed to be uniformly within the capsules and centrally located in the collimator slots. Whereas on the right-hand side, it's an example of the reduced source inside the standard conventional nucleonic device is made up to just the 7 source capsules, each containing, again, 1.1 gigabecquerel 30 millicurie source of cesium-137. The source were assumed to be uniformly within the capsule and centrally located in a source capsule. It's up to Oliver about the other aspects of the profiler.
So the profiler is radiography resilient as well, and the collimation of the profiler has a positive effect on this. If the vessel entry is required, there's an isolation handle that pulls the sources out of collimated alignment to shield them for safe entry to perform cleaning or maintenance, as demonstrated in that short animation. As the instrument is internally mounted, there is no radiation measurable on the vessel wall from the profiler, and that's due to the low activity of the gamma sources that we use. These do not have enough energy to penetrate the process fluids other than what we need and want for the measurement. So this is what an operator would typically see from the control room, and the screen can be seen from one central location or from the HMI, with an accurate overview of the plant status in real time. And these alarms allow for quicker reactions in the event of anomalies. The system can store both real-time and historic data, which is now able to offer enhanced diagnostics, remote calibrations, and better management of the vessel. Clients can use this information to aid in the vessel cleanout. One of our clients said that before installing the profiler, they would have to run the sand mud wash system on a number of occasions before a shutdown, and the cleanout would take around 3 days. Now they've got the visualization inside the vessel and can see the deposits in real time. They could increase the frequency of the jetting and reduce the clean-out time to only a few hours. In the next slide, we're going to look at a desalter operation and some of the typical challenges that can be seen. So some of the challenges that include in this are the blending of feedstock for accurate level measurement, corrosion and wastewater management. And when the water level rises and it's not detected, the emulsion phase might reach the plates, shorten them and causing the desalting operation to fail. Tracerco's high temperature profiler would provide live monitoring and process control, preventing this from happening. The animation is going to show how a profiler will be installed very simply into a nozzle, and this would allow to give much greater feedstock flexibility. It also allows for better timing of the chemical usage, greater operator confidence, and cleaner water on the outlet. It also reduces the amount of unplanned shutdowns and a greater throughput. It's also going to show a graphic on the right-hand side, which is similar to what the HMI will show in real time for the output. So using these outputs, you'll be able to see the oil, water, and emulsion or foam to the extent of any buildup in the vessel. And the profiler can have both level, alarm, and trip functions taken from the same profiler and the same output, which should prevent any dangerous configurations from happening. So the advantages of the profiler include the ability to characterize in real time accurate process conditions, allowing operators to make data-driven decisions. And there are no moving parts, so there is a very low maintenance requirement. With the resolution improved control available, there will be reduced operating costs from more effective chemical control and a reduction in the manual sampling frequency. There will be improvements downstream as well, with more efficient salt removal, and there's going to be less overrides that are required during radiography, as the instrument is resilient to the majority of the conditions. With this greater interface control, there'll be reduced carry under, also improving the environmental compliance. Rufat's going to talk about one of our customers' success stories in the next few slides.
Thank you, Oliver. So Tracerco was approached by a refinery to help diagnose and understand the root cause of the process issue in their crude distillation unit. During a recent turnaround, significant damage was discovered in several distillation towers, primarily due to corrosion, and issue was with the tray position and quality of the product. It was suspected that a poorly performing desalter may have contributed to these problems. Just when we spoke with the client, it was found that the client didn't have any nucleonics, it's just a conventional instrument. So we've been asked to assist them. Tracerco collaborated with the refinery to apply its process diagnostic technique and services on the crude unit, including neutron backscatter. That's how the diagnostic services perform. This non-contact technique can be quickly deployed while the vessel remains online, allowing the real-time assessment, while without any shutdown, of liquid levels, interfaces, and overall process condition to help determine the failure modes that led to the tower damage. So that's basically that actual operation example, what we had. The MBS scans was carried out on the both desalter vessels in a parallel train at the previous running condition. Additionally, as part of the study, Tracerco also scanned the several operating conditions, which include variation in crude blend and water rate to look at the effects on the interface. During the scan, it was discovered that malfunctioning of the conventional level transmitter led to carryover of emulsion in the oil stream in distillation column. In turn, corroding overheat due to increased chlorides, and there was also carry-on of oil in the water, affecting water purity and environmental non-conformances. So the next slide showing that in comparison was previously, we see that's defining how the typical Newton backscatter results should look like, where the signal change between the hydrogenous layer and clearly defines. This is indication that vessel is working as per the design condition. However, the actual results from the study indicate that wasn't clear in difference between the oil-water interface. As a assumption, following analysis of the result and in consultation with the Tracerco client, with a Tracerco profiler was chosen to replace the all-conventional non-nucleonic instrument in an existing desalter instrumentation to simple integrated interface, control, and monitoring devices, using gamma ray absorption to measure process fluid density and a position by the change in radiation intensity. The instrument provides an accurate measurement of the process fluid distribution within the desalter, offering continuous high-level imaging and control of each phase. As part of the total system analysis at the desalter unit, Tracerco also provided T251 density gauge in conjunction with flow and volume measurements on the crude feed line to monitor density of the blended crude charge as part of the ratio control optimization. With repeatable, accurate, reliable real-time process measurements, the profiler provided the client with the confidence to correctly control operating level, enhancing separation. So the Tracerco also, as part of the solution, Tracerco also provided proprietary software to the client for that measurement system and control solution. It's a ready-made graphical interface, providing clear insight into separation quality whilst enabling efficient operation and control of the instrument. So that display option available for HMI provides the clients with what they called window into the vessel, allowing operators to visualize the process density distribution and utilize the diagnostic data. The HMI offer the easy access to process and instrument status in real time, as well as the trend data, allowing adjustment to the process to be monitored, change on the run online, enabling decision to be made faster, analysis easier to understand a greater depth of optimization. The instrument is now be fully integrated in the client's DCS. That's also one of the option part. And here, that's an example of our historical trend. The HMI can actually log up to 12 months of the historical data. And also, as Oliver showed the previous slide, there is other example of the HMI screen. They can be used to diagnose process problems and optimize by providing the data.
So in the months after the installation of the profiler, on the first stage desalter, a number of key and measurable benefits were realised that enhanced the unit's performance and reliability. Due to the industry-leading vertical resolution of 30mm, the client's confidence in the interface level was increased, which led to optimising the interface for maximum wash-water contact, reducing the emulsion breaker chemical dosing by 50%. In relation to the crude quality, the refiner noted a 44% reduction in the basic sediment and water, and also an improvement in the salt removal efficiency of the unit, with a reduction in the chlorides by 50%. The demand on the atmospheric distillation tower preheat furnace was reduced due to eliminating excess water on the dehydrated crude to provide a more favourable approach temperature. And this also had an impact on reducing the corrosion of condensing overheads and towers from hydrochloric acid due to the excess chlorides in the heated stream being removed more efficiently. Coupled with the enhanced instrument accuracy, the unit had no process trips resulting from lack of control or upsets due to interface incursions to the lower grid, and that equated directly to an increase of 2.5 operational days per month. Although it's certainly not limited to these applications, the profiler has proven particularly successful in the applications below. As each design is tailored to the exact requirements of the customer, we are able to use it in almost any application. And that pretty much brings us to the end of the slides that we've prepared, so thanks for taking the time out of your day, and would welcome any questions that you might have. I'm going to hand back over to Ken.
Thank you very much, Oliver, and Rafat as well. Let's go ahead and get ourselves into Q&A mode. I'm going to put up Rafat and Oliver's email addresses if you want to get in touch with them. I'm going to start with a question that came in about remote calibration. How is remote calibration performed on the profiler, and does the vessel have to be offline during that?
So the remote calibration for the profiler can be done in a couple of ways. The one that we've developed most recently is a method where we will collect around a month's worth of data from the DCS system. And this month's worth of data will collect individual data points. So each profiler can have up to 75 measurement points. And what we do is we analyze every one of those detectors for the density and count rates and compare it to what should be expected during that. So once we've completed that analysis, we'll be able to provide an ideal and realistic calibration file for the vessel while it's online in operating conditions. We can then send that file offshore or onshore, and it can be uploaded directly to the profiler in about 15 minutes. So there's very little downtime of the equipment.
Fantastic. I think I'll go ahead and just put our cameras up a little larger. We've seen the slides long enough. And I'm going to move on to a question asking, what is the typical working life of the instruments?
So the working life of the radioactive sources is recommended as 15 years. After the 15 years is up for the sources, you'll have to increase your radioactive leak testing from biannually to annually and make sure that there's no increase of doses seen on that. For the instrumentation itself, the recommended working life is about 10 to 15 years, and this is more based on components inside of it. It's not that we expect it to start failing as soon as it reaches that, but that's the time when the electronics should be considered for change out, and certainly the 15 years for the sources.
Okay. A couple of questions about buildup. I think some people are referring to buildup on the profiler and some on the vessel. I'm going to start with the profiler. What about buildup on the profiler? Do you need to flush or do something else?
And well, basically, for the profiler, as I said, it's installed on various sites on a various field where you had a different gravity, a different property of the oil or hydrocarbons, and there is a different type of intensivity. Because of the uniqueness of design and the software as well, the profiler can differentiate that it is a buildup, and it could be visually seen on the HMI screen. However, for the 420 milliamp output, for analog outputs where you can actually see the level, it doesn't affect because that's a software differentiate that it is a buildup, it density changes, or it is a unique level. So it basically depends on the level of the deposit. The profile is resilient to the buildup on the probes. However, if the customer has a challenges with a very heavy crude oil, where the deposits it will be in a short period of time, we can actually, as I said, that it's not only a product, it's a solution. We provide some type of solution as well, a kind of like a mesh guard or Teflon coating as well to minimize effect of the deposit as well.
Okay, thanks, Rufat. I'm going to follow up now with vessel buildup. And somebody asked, how much buildup can your detectors see through?
Oliver?
So the detectors can see through varying ranges, and it'll depend on what's inside the vessel and what buildup it is. If we're using one of our standard americium gauges, we can see through a couple of millimeters of typical buildup, such as mud or crud that's been built up around the probes. If we use one of our cesium profilers, we can see around 12 mil through that, and that's usually enough that it sees through the majority of it. And if the vessel's getting particular build-up to certain levels, what you'll actually see is a change in counts or density on those bands, and that'll be shown as sand or a different solid on the HMI screen. So you'll be able to actively look at that and determine if you need to do any vessel maintenance, cleaning, or schedule it in for the next shutdown.
Okay, great. And I had a follow-up. The person who was asking about the lifespan, you said 15 years is typical, and they just asked, is there any recertification required during that lifespan?
No, so the certification is done at the manufacturing stage. So we will look at which region it's going into and make sure that what we provide is suitable and allowed inside that region. So that'll be whether it's a different source size or a different sector. And that'll be certified from the start and provided in the project documents. Once that certification is done, there's nothing to recertify on it. At the end of the 15 years, though, for the sources, it's not that it falls out of certification. It's a recommendation that the upgrade is or the replacement is considered and the leak testing is increased. but that will fall in line with local legislation for the radiological rules as well.
All right, different topic point. What is the minimum nozzle size we can use for profiler installation?
So the minimum nozzle size we're talking about is going to be 4-inch. However, we have some application where clients ask us to use their 3-inch nozzles as well, but where we can actually try to find a solution. It depends on the pipe nozzle schedule as well. But that's typical 4-inch minimum and up whatever you can actually install.
Okay. Can the profiler indicate foam?
Absolutely, yes. It is basically the profiler. It's primarily installed on most of the separators across the world, and where they can control the foam to prevent any foam carryover or reduce the foam agent as well. It's a treat as a same as you detect emulsion, and you can see the density of the foam as well. Yes, it is indeed. As well as our just a normal standard nucleonics level plus, they can actually define where is a foam incoming or not. We can actually calibrate that system as well.
Very good. Let's move on to, here's a good one. What kind of outputs can be provided with the profiler? Does it only measure the interface or also top and bottom of the emulsion and water level?
So, as I said, as a profiler is a unique solution. So we can actually provide up to 5 configurable outputs per interface. Each interface has a one own outputs. So it's a 5 outputs, analog outputs, 4 to 20 milliamp, which can actually measure top and the bottom of the interface. At the same, we can provide a digital output, which you can actually implement on HMI screen, as I showed before. You can monitor the density band as well. So what's the density on the profile and each stage, as it was we just discussed about previously. They can actually see that's what's the density of the deposit or sand or oil as well. It's helpful for the process engineers as well. They can actually see that's what's the process density they actually have inside the vessel.
Okay. Let's take this one. Do you help with the local licensing of the radioactive sources?
Yeah, so we have a dedicated team of RPA that can help with that alongside the project technicians or project managers. We wouldn't be responsible for completing the application, but certainly for everything that's required inside of it, we can provide the information, best experience from other projects, and we can certainly put you in touch with RPAs if you need commercial advice at that stage as well.
All right. What is the resolution for each point of the profiler?
So, as I said before, the profiler can be various resolution. It depends on the customer's needs, but we can actually be each point actually be as a 60 millimeter as well, the rate per point. So you can increase and decrease as well. Again, it is bespoke, so it depends on the customer. We have customers who actually ask the even higher resolution than 60 millimeter or the lower resolution as well. It's so, and also the profiler, sometimes the customer doesn't need some high resolution on certain levels, so we can actually provide a different resolution at different level of the vessel.
Okay. Do we need to stop processes to install sources and detectors, and what calibration method is required?
So yes, you would need to stop your process to install the dip pipes. Depending on if it's a new vessel installation or if it's an existing retrofit, then it'll depend on when you would do that. The dip pipes will need to be a break of containment, so that'll be physically attached to the vessel. Once they are attached to the vessel, you can then commence your operations. It's completely sealed, but there would probably need to be another little bit of downtime to physically install the profiler. We usually recommend for the first calibration that you would do a vessel fill across the full range and then also drain it to verify that. What was the second point of the question, Ken?
Calibration method.
Okay, yeah, so calibration method would be typically a vessel fill, or we could do a vessel fill preliminary, and then after you've been operating for a month, we can review your data and give you a hot calibration, which is in relation to the operating conditions and a really good and accurate calibration.
Okay. Here's somebody asking about case studies, I guess. What operational efficiencies have other refiners seen from installing a level measurement system?
As I said before, there is a lot of lots of publications as well. There's a lot of case studies on various sites where it's already available as well. If you actually search by profiler case studies, and we have seen that's how it's good stories as well, where the clients had the issues was on site with the process and products, and since they installed the profiler and the success stories, as well as if a customer asking also we can actually reference to the other assets. We can give the provider different assets contact details for the same client. They can actually talk to each other, and I'm sure they can actually find a really good success stories on that as well.
Let's move to another case study type question. Does this help increase production uptime?
Yes, it does. So with the production and the more accurate data that it'll give you, all of our instruments will give you the real-time insight inside the vessel. So you'll be able to look at if there's anything happening in the process that might lead to maintenance being required. So you can plan the preventive maintenance as opposed to being reactive. And in some instances, you'll be able to see if things are damaged inside the vessel with another change as well. So there's many ways that it can increase the production uptime.
All right. I'm going to pick, here's one. We are blending low carbon feedstock. Will your profiler work in this situation?
Yes, it's absolutely yes, because the profiler itself, it's not only designed for the hydrocarbon measurements or oil and gas fields or petrochemicals. It can be used on oil and gas industry as well. So we used some case studies or a request for the provided solution for the for low carbon feedstock as well. So yes, absolutely, because it doesn't requires oil, it different density measurements system.
All right. We talked about foaming before, and somebody wrote in a reply here or follow up asking, can your level system prevent foam passing in the gas phase to our compressors?
Yes. So the profiler will be able to detect the foam, and it'll give you that output onto the DCS or the HMI. You can also set alarm points for it. So if you wanted a trip coming in, if the foam reached a certain level, you could take that off the same system. So you can have multiple alarms and levels coming off the same output, going into trip relay outputs. So yes, definitely.
Okay, as long as we're talking about what it can spot, here's somebody asking, can the density system collect data on erosion or thinning of a pipe?
Yeah, so if the process has a continuous fluid running through it that has the same density all the time, you'll be able to infer from the count data that if the pipe is changing. So if you're going to see a reduction in the density measurements, that means that something is letting more counts through or more radiation through. So that would indicate that there's thinning or corrosion on the pipe. And also with our toolbox software, you can log on and you can see really good advanced diagnostics in it for both the detector health and for things like the individual count rates of the tubes to further drill down into that. And if you did want more analysis doing of that data, you can send it over and we can give you insight into what we think's happening inside the vessel.
Excellent. Back to calibration. Here's somebody asking, if we change the process conditions, do your instruments need to be recalibrated?
It depends on what changes. Some of our instruments will use full radiation cutoff, such as bulk level. And if they change, provided the radiation is still being cut off, then it's unlikely that you'll need a full recalibration. If you're changing the process entirely, then yes, we probably would recommend it. With the profiler, though, if you're just bringing on a different crude or a different well, we can actually just change the set point of the oil. So the calibration looks at the density for a set density of fluid, and after that you can recalibrate it or reset the depth, the set points to match the new settings, and that can be done online without taking the vessel out of service.
Okay. Are there any design conditions that we need to account for instance, maximum pressure or temperature that the profile will operate under?
So basically, when we design the profile of a solution, provide a solution, we usually consider that what's a process design, vessel design as well. And we provide variants of the profiler. It is we have starting from low temperature profiler to high temperature profiler with a maximum 170 degree temperature. However, we have some case study we requested as well. Can we use the profile even a high temperature environment? It is all of course it is all depends on where the profile in situ, condition, certification, and we do the bespoke design. That's definitely. It's not off-shelf product which is limited. It is basically we consider all aspects: geographical, ambient temperature, design, certification, country where they're going to be installed. All these aspects will need to be considered.
Okay. Well, gents, you did an excellent job. Very efficient. Got us through all of those questions. I think we can go ahead and wrap things up a little before the hour, give people a chance to get a cup of coffee or tea and move on to their next meeting. And on behalf of Rufat and Oliver and everyone at Tracerco, thank you for your attendance and enjoy the rest of your day. That concludes our session.